Good day everyone. My name is Arun Kumar on behalf of my team for the project named Real-Time Kuala Terengganu Driving Cycle Big Data Analysis by using Driving Cycle Tracking Device, or in short Dctrad. We are from Faculty of Ocean Engineering Technology and Informatics, Universiti, Malaysia, Terengganu. Before proceeding to our presentation, let me give you a brief outline on what we are going to present to you today. First, we'll have a look at what are the problems faced by us recently. Second is the originality and the commercial potentialities of our research. Third is our research objectives, which consists of three objectives, which is prototype construction, database management, and also driving cycle construction and analysis. In this presentation, we will also have a look at production costing, significance of study, and a list of publications we have done on this research.
Let's start with an introduction of this project.
Driving cycle is commonly known as the relationship between a set of vehicle speed points and time. The study on this discipline aids the vehicle manufacturers, environmentalists, and traffic engineers to further investigate for a better energy-efficient vehicle production. To develop driving cycle for a route, data based on real-world driving behavior has been crucial and leads to the idea of construction of driving cycle tracking device Dctrad, which is a device to collect the data on speed and time of the vehicle and updates instantly on cloud. In this project, a smart real-time monitoring and control system on Kuala Terengganu City route driving cycle is implemented. The project is involving Internet of Things (IoT) solution in order to receive, transmit, and store the large and big data throughout the driving process. Generally, the well-known drive cycles such as the WTC, Worldwide Harmonized Light Vehicle Test Cycle, and EDC, New European Drive Cycle, FTP, Federal Test Procedure, and Japanese modes were seen originated from Europe, United States, Japan, China, and India, which are significant in the global automotive industry. Driving cycles are commonly used in legislation by governing bodies in the effort to control the emission and fuel consumption. Driving cycle also used by vehicle manufacturers and automotive suppliers for product evaluation purposes. In Malaysia, an EDC is still being used by the local authorities for legislation purposes and by the local manufacturers and suppliers for evaluation purposes. Even with the transition to WLTC, the need for a local drive cycle is mainly to contribute towards accurate fuel consumption assessments for Malaysian actual driving cycles, specifically in Kuala Terengganu City. In order to develop a driving cycle, past researchers requires the effort and time to go to the route just to collect all the data to produce the driving cycle. Some take weeks, months, and even years just to complete all the data needed. The proposed system will have an accurate real-time traffic data collection equipment to yield viable outcomes. However, tremendous and big parallel data for thousands of seconds data will cram the system and will cause various problems. Thus, the problem stated has led to this project, which is this project shall contribute greatly to the development of Malaysian actual driving cycle. These IoT-friendly systems and operations enable manufacturers to improve the quality of their product in real time. The aim of this project is to fill the middle ground market, which complies with both professional requirement and also fulfill the automotive enthusiast market. Available systems in the market are way high in price, including the product training and simulation software price. This proposed project is low in price since the hardware part is way cheaper and the software used is the open source software and easy to get. In the market fit measure, the system architecture and the outcome are very attractive, especially when paired with low pricing.
There are three objectives involved in our research. First is to develop a prototype of Dctrad. Second is to implement the big data management and analysis. And the last objective will be to construct the Kuala Terengganu City work route driving cycle using MATLAB software. Let's have a look at some of the methodologies involved in our research. Now, let's have a look at the methodologies. In this research, several activities are involved. First is to set up all the components for driving cycle device and attach the device on the car. Second, the GPS will be capturing all the driving data and send the data to the cloud database via MySQL or a pushing server XAMPP. Third is to pre-process all the messy data collected, data reduction and also feature extraction to filter all the noises involved. Fourth will be the characterization of driving cycle. Fifth is to develop a driving cycle using MATLAB Simulink conceptual design. Next, let's have a look at the first objective or prototype construction of driving cycle tracking device, or in short Dctrad. 3 steps are involved in this objective. First is component selection. A few components are used in this step, which is ESP32 module, GPS Neo 7M, jumpers as needed, 5-volt power supply, Arduino IDE software, pushing server or XAMPP, PHP MyAdmin. The second step is to connect GPS to ESP32 module. The GPS VCC pin will be connected to ESP32 5-volt pin. The GPS ground pin will be connected to ESP32 ground pin, whereas GPS RX will be connected to ESP32 TX, and also TX of GPS will be connected to RX of ESP32. The third step is the programming. 3 different codings are involved in this research. First is SQL code to prepare table in database. Second is PHP code to push sensor data to database. And third is the Arduino code to process GPS and also ESP32 units.
Now let's move to objective 2, which is database management. The driving data from MySQL will be exported to the MATLAB software, and then the data will be put in a data store, and then we will pre-process all the data, all the messy data, and then convert the data store to tall array, and then extract a subset of data that we needed. In this project, we only need speed and time, and then run code on the subset of data what we want to analyze. In this case, we want to analyze the characterization, which is 9 parameters of driving data, and also the driving data for driving cycle development.
The third objective of this research is the driving cycle construction. 3 steps are involved in this objective. First is to construct a conceptual design of Dctrad in MATLAB Simulink. Second is to upload managed data from MySQL into signal builder function block of the conceptual design. And third, the driving cycle constructed in scope will be analyzed. Next, let's have a look at the results obtained in this research. As we can see in this slide, the first image shows the overall view of driving cycle tracking device. We have a 3.5 inches TFT touch screen which displays the speed in km/h, real-time clock, laps, average speed and also distance traveled. As we can see in the second image shows the data uploaded into database from Dctrad, and the third image shows the filtered and managed data of the data in the database as per image 2. The fourth image shows the driving cycle construction in MATLAB Simulink, or in short, the conceptual design of driving cycle tracking device. As we upload the managed data into the signal builder of conceptual design of Dctrad, a scope as per image 5 will be out. The first axis shows the distance traveled. The second axis shows the driving cycle or the speed versus time curve, and the third axis shows the acceleration in G unit, which is retrieved from the speed data of the vehicle.
From the MATLAB Big Data Management, we can develop a Kuala Terengganu driving cycle analysis as in the figure. And we also can analyze the parameters from the driving cycle itself, which is distance travel, total time, average speed, average running speed, average acceleration, average deceleration, RMS, which is root mean square, percentage idle, percentage cruise, percentage acceleration, and also percentage deceleration. The following observations are made from the developed driving cycle. First of all, speed range above 10 km per hour was dominant. This is due to busy and medium traffic condition of Kuala Terengganu road to work route. The microtrips at the higher speed range are longer compared to the microtrips at lower speed range. This is because the vehicle experiences a free flow mode at higher speed range with less frequent stop due to less traffic condition. A 35.15 km per hour average speed was recorded in the developed KT driving cycle, shows the vehicles are moving at lower speed and more microtrips are found below the average speed. Therefore, more fuel consumption and emissions take place during that period due to frequent stops along the route. Final Kuala Terengganu driving cycle fuel rate and emission analysis retrieved from autonomy software using PHEV powertrain. The fuel economy is 19.49 km per litre. Fuel consumption is 1.11 litre per 100 km, and CO2 emissions is 26.1 gram per kilometer.
As for production costing, as we can see in this table, the cost of construction of Dctrad is 203 ringgit 50 cents in total, which is much more lower compared to the devices we have in market.
The significance of this study is that this project will be introducing an efficient solution to society, environment, economy and world by characterizing and constructing real-world Kuala Terengganu driving cycle, which results in less dependence on oil and reducing the effect of global warming. Proven successful government annual spending for pollution recovery could be reduced. The project also will increase the awareness of the energy consumption and emissions. This project also responded to the IR 4.0 mission by implementing the IoT system with the big data analytics. For further projects, some improvements can be made, such as broaden the area of big data analytics to other transportation services. This is the list of publications that have been accepted and published related to this project.
As we can see in this last slide, the first image shows the constructed Kuala Terengganu driving cycle, and the second table shows the finalized analysis of Kuala Terengganu driving cycle. In conclusion, the driving cycle tracking device and also conceptual design of Dctrad is verified, as the percentage errors of most of the parameters except percentage cruise is within acceptable range, which is below 10%. Therefore, that's all from us. Thank you.